Hi friends, this is EL6503 cell phone technology taken by Dr. M.R. Gadhvi. In today's topic, we are discussing the 20.3 digital cell phone system. The previous lecture was discussing on the AMPS, that is the Advanced Mobile Phone System. Now with context to this title, the understanding is much clear that AMPS is about the analog communication method. However, the discussing right now that is about the digital communication system or digital cell phone system, and that is what the cell phone today's we have or the new cell phones. So with this we begins that how all the digital systems were developed primarily expanded the capacity of the cell phone system, which is already into place and already are in the use. The rapid growth of the numbers of the subscriber or the users were force technology to switch from an analog system to the digital system, and digital system having a many advantages. They are more efficient and efficient, they are increasing in the numbers, and users of a system could handle very easily. So digital system was in a way it was a mandatory, as the cell phone was widely used by almost by every the next step having the mobile in their hands. And even today if we are looking around us, then out of 10 9 people having the mobiles, and they are using undoubtedly with almost all features. So let's have to discuss the digital cell phone system in brief. Now the digital technologies was brought several additional benefits, like a digital communication system is robust and compared to the analog system, and it is more reliable in a noisy environment. That means the noisy environment or the interference are occurring around us, or the electrical noise or communication noises are there, then compared to the AMPS or the analog system, the digital system was quite efficient. And there is a one more advantageous part, that digital circuits can be made smaller, and therefore it is a very much power efficient, whereas all the analog components are power consuming, and therefore the even in spite of the battery based devices, their life or the consumption life will be very less in context to the digital. So again digital cell phone is more advantageous. uh, there is a one more thing is the handset can be more compact. The handset can be more compact, and where it is, I'm sorry, yeah. So the handset will be more compact, and since it is compact and it is power efficient, so the battery's life will be also increases. Finally, the digital phones are generally facilitates the transmissions of the data, not only the voice but the data services like email and internet is also easily accessible in the case of a, digital cell phone in compared to the AMPS. So if you are making a list, So many advantages are there. First of all, it's a robust, that analog having the chances to get not work. Suppose it's fall down from your hand, and the digital phones having a less chances, because everything is printed on the circuitry board, whereas in digitals, in analogs, it's a not like that. Because the smaller circuit, it get compact, and the cell phone become more compact and portable, and the less weight, and the uh, thin, and everything is possible, whereas AMPs is not there. It can run very easily in even in the noisy communication or noisy environment, whereas AMPS is not. The data transmissions for the voice as well as the other than voice, that is the data services like email and internet, can easily incorporated with the digital part. So this all are the list of this one. Anyway, in the modern digital cell phone refer to the second generation, in context to the second generation phones, right? The first generation was definitely the AMPS, but the today is the very well known is the third generation. And I think when this book was written, it was the third was latest. Nowadays we are hearing about the fifth generation. Maybe you guys are, when you reach to your prime age of 40s, maybe fifth generations will be the part of the society. So that is there. In between the 2G and 3G, there is a one intermediate stage, and that is known as the 2.5 phones or 2.5 generations, which is the intermediate, and that generation doesn't sustain which is long, because there is a very small enhancement compared to 2G to 3G. Only the speed variations was there. So anyway, we will check it up the 2G cell phone briefly a little bit, and then 3G and 2.5G will be the part of your annual examination. So I will be putting a lecture after this CIA2. So this is the last lecture of the CIA2. I'm sorry that giving you the lecture notes and lectures in very late stage, but I'm pretty sure the syllabus I'm keeping low, so you don't have any problem in the exam. Okay, so this is the 2G or the second generation cell phone, rather I should say it's a second generation digital cell phone system, and which is widely used even today. So it is observed that more or less it is with the time divisional multiplexing technology, and the third one is something like known as a spectrum or the spread spectrum technology, which is nothing but the coded or CDMA coded technology. Europe and majority of the world are always working with the GSM system or the time divisional multiplexing system, but US is using both the variant, that is a GSM as well as the coded technology or the SS. It is nothing but the you can look at here, SS system is nothing but the coded multiple access or the CDMA. So this both technology do available in the US, but Europe and the other part of the world is only stick to the GSM. Now let us take an example how exactly digitization is taken place over here. So we are knowing that coder will compress the voice code signal, and thereafter it is modulated and transmitted to the through the transmitter, and when it will receive, the reverse cycle will take place, like demodulation, and then the code will be decoded, and again the voice signal will be retrieved out of this. The only limitation with the uh, spread spectrum is that there is a limitation number of the subscriber. If you have having a very large number of subscriber, SS having a restriction on it. Okay, now vcoder is a special type of analog to the digital converter, and as well as you require a digital to the analog converter in the vocoder. Then only the analog voice signal will be going to be uh, compressed. So if it's a pure AMPS phone, then the vocoder system is directly analog system is going to be compressed. But now the vocoder need a one intermediate circuitry part, that is a AD to DA, that is a analog to digital and digital to analog converter is needed. So let us assume that 8 kilohertz, that is this means that the AD converter V code should have the voice signals at, I'm sorry, AD converter is voice signal is that means so let us say I am taking an example of voice chord conversion, and the signal frequency is 8 kilohertz. So at this means that the A to D converts the voice signal, and voice signals is converted into the serial converter. Okay, so the one by one signal is converting. Now if you did 1 kilohertz, if you convert into the frequency, so 1 upon 8 kilohertz, so that would be the 125 microseconds generates the proportional binary word, assuming that 8 bit during the 125 microseconds. And if it is so, then what will be the rate at which one bit will be transmitted? So I am dividing 128 by 8, because one binary word I am assuming with the length of 8 bit. So if 125 microseconds is voice code is generated, and that is of 8 bit, then I should divide 125 microsecond by 8, that is a 15.625 microseconds per bit. Or I can take it that 1 over 15.65 into 10 to the power minus 6, so that is comes out to be 64 kbps, that is a kilobit per second. Remember that kbps, which is we generally use in the our internet speed and so on, because it's a serial transmission. So whether it's a data or it is a voice code or it's a voice signals, everything, because nowadays the digital technology is always there, so naturally transmissions will be on the basis of digitization form. That means what you are speaking in your phone, that is converted, must be the conversion should take it place from analog to digital, and thereafter digital to the serial transmission will takes place. And once it's a serial transmission, so you can understand this logic, right? Still I have put it on the piece of paper. So let us say A to D converter into the vocoder is at 8 kilohertz, means vocoder will generate a binary word. I am underlining the binary word, that means let us say it's a 8 bit, we are assuming that. So that will be the 125 microseconds. How it is possible? That is 1 divided by 8 kilohertz, that is 1 divided by 8000 hertz, and that is equivalent to 125 microseconds, correct? So let one word is of a 8 bit, then transmitted serially, then 125 microsecond by 8, so that would be 15.625 microseconds per bit. To transmit a 1 bit signal, you require 1525 microseconds, or you can say that 1 over 15.625 microseconds, that means beat per second. So ये microseconds हो गया, so that become a 64 kbps. So it's a kilobyte per second, kilobit per second. Okay, so with this I can ask a few example on basis of this, and you can let us I can say 10 kilohertz, so you can calculate according. I can say 5 kilohertz, and just keep that the word will be of a 8 bit, so the calculation will be easier. So with this I stopped here. 2.5 generation and 3 generation we will discuss later on. All the best for exam. Do well, do best. Stay home, stay safe.